We are in the home stretch. It's April. I only see you for 3 more weeks, I think, basically. 2.5 more weeks, actually. Good old Ann Serkey. How much work is done? Well, one definition of work is force times distance. A little reminder, I'm doing the Physics 11 unit, but it's really Physics 12 because we're doing it in Physics 12. It's going to be 767 times 28. I did a quick check, Diego, because for me to use this equation, the force and the distance have to be in the same direction. They are. I have no idea what the answer is here. 767 divided by, no, not divided by 28, Mr. Duke, times 28. That would have been silly. I get 21,000. I'll write 21,500. Actually, I looked at part B. I think I'm going to need to use this answer, so I'll write the whole thing and then I'll round off. 21,476. And I'll report the answer as 21,500, and work is measured in joules. 1 mark. Suppose they complete this task in 58 seconds. Well, power is work over time. So it's going to be 21,476 divided by 58. And I get 370 watts. About half a horsepower. Yes? Quick money. The key word here is lift. How much work? Here, the work is going to be mgh, because the force that you're lifting against is gravity, so the force you have to exert up is gravity, equal to gravity. So it's going to be 688. Found it yet? Hey, I knew you would. Times 9.8. And your response should have been, yeah, Mr. Duke, at least I'm in the right class, right? Yeah. 688 times 9.8 times 2.8. I got 18,878.72. 18,879. I'll write it to 3 sig figs. 18,900 joules of work. Power is work over time, so it's going to be 18,879 divided by 73. I still have this stored on my calculator, so I'm going to use my answer button. Do I get 259? Is that right? 259. Power is measured in watt? Is work a vector or a scalar? It's a scalar. Work is measured in joules, or you could have said Newton meters, since it's force times distance. That's actually what a joule's definition is. It's a Newton meter. 1 Newton of force to move something 1 meter, you have done 1 joule of work. Power is measured in watt, which is actually a joule per second, because power is defined as work over time, so joules per second. What is the, okay, power. It's going to be work over time. Climbs, I think, lifts, so it's going to be mgh over time. The mass is 64, g 9.8, h, first of all, 21 centimeters, nice try, 0.21 meters. It's going to be 82 times 0.21, because 82 stairs times 0.21 divided by 83 seconds. Power is measured in you get 130 watts? One mark. An electric motor lifts a load a vertical distance of 24 meters. Lifts, Mr. Duick. What is the power output? Power is work over time, so it's going to be mgh over time, so it's going to be m 25, g 9.8, h 24 all over 32. You get 184? Is that right? 184 watts? Yep. If the motor, so that's the power we got out, 183.75 watts. But the power that went into running the motor was 244 watts. That means there's an extra roughly 60 joules every second that's being bled off as wasted heat. So how efficient is this? Efficiency is power out divided by power in, or work out divided by work in. It's the smaller number divided by the bigger number. It's going to be 183.75 divided by 244, and then multiply by 100 to turn it into a percent. %75.3% efficient. We lost almost 25% of our power, our energy to heat. How much work did the applied force do? Well, I think the work done by the applied force is going to be the applied force times distance. Oh, there's my applied force. And horizontally, it slides horizontal, so the force and distance have the same direction. I get 910 joules of work. B says, how much work does friction do? Well, the work done by friction is going to be the force of friction times distance. By the way, a synonym for the work done by friction, that's how many joules of heat you generated. Heat is the work done by friction. It's the force of friction times distance. So, this is a job for a free body diagram. Gravity, normal force, F applied, friction. Okay, it's going to be mu times the normal force times distance. Mu is 0.25. I don't know the normal force. Oh, but look, another force same size as the normal force, mg. So it's going to be 12 times 9.8 times the distance, 14. Missed the decimal. You all get 412? 411.6. So we put in 910 joules of work by pushing, but not all of that went into making this object speed up. Except 412 joules went into heating up the floor. So what's the net work done? It's going to be 910 minus 412. I'm going to use my answer button. So it's going to be 910 minus answer button. And I get 498 joules of work. That went into causing this object to speed up. Which, by the way, means if you knew what its initial velocity was, that's how much kinetic energy it's gained. You can figure out its final velocity. Can you give yourself a score on this quiz? 1 mark each, so it is out of 13. And then if you'd be so kind as to pass them inwards. Thank you.